Today we are going to be going over alkanes and the basics on them. So, um, basic information out of the way. Alkanes are only, well, okay. Should say they're mainly, I'll say, mainly carbon and hydrogens with single bonds. Okay, these are the simplest organic molecules. And when we think about their function, I mean, really, they're just they're good for combustion, but not much else. And so when we're thinking of some alkanes, actually, you know what? No, we're gonna get rid of that. This is actually only alkanes are only carbons and hydrogens with single bonds. Got confused for a second there. Sorry, guys. So simplest organic molecules, good for combustion, and that's about it. Some good examples of these are CH4. That probably looks familiar. That's methane. Why did I write it like that? Whoa. Methane. How about we go up? Next one. That's ethane. Go up again. Bam. How about propane? Recognizing the pattern on the carbons and hydrogens going up? You should be. This would be butane. And then something I will touch on in a bit here is the constitutional isomers of butane, because you could also have a different version of this, and that could be called isobutane. So if I were to write this out, butane could be CH3, CH2, CH2, CH3. But isobutane, CH3, CH, CH3, but then it comes down here, you have a CH3 there. That looks a little different compared to that one. Looks a little different. And what I said was that these two, boom, boom, oops, butane and isobutane are constitutional isomers. They have the same formula, but they look a little different. You can see that. You can see that there. Now, in my organic lecture, we have to memorize certain isomers dealing with propyl and butyl groups. So I'm going to write that here because I am fairly certain that that is fairly common. So I'm going to say, remember these. And I'll draw them out too. In my notes, I just had written the names, but I never drew them out. So we're going to change that. So first one I'll say is isopropyl. Propyl is the 3 carbon. You can see up here. We had propane. That's C3. So we have isopropyl. So that'll be, and then here I'm gonna. So what this is, that's just like what it could be bonded to. I don't necessarily have to draw that, but I like to draw that to show that it can be bonded to something else there. That's just me. That's a me thing. But here you can see that we have isopropyl here. You have your 1, 2, 3 carbons there, and it kind of looks like a V. Kind of looks like a V. Next is, let me think. How about sec-butyl? Going to the butyls. Get away from the propyls. Sec-butyls look like that, and it can be flipped. You can flip these all over the place. I mean, they really, and then yeah, these can be flipped. I mean, that doesn't even have to be on that one. It can be down here. But usually it's on one of those or one of those. That makes it sec-butyl. Next one is isobutyl. Oh, whoops, I didn't mean to draw a space in there. I'm doing that a lot. Isobutyl. I need to space these out a little bit, but I think it's okay. Just draw a little small. Isobutyl. So I'm going to say, coming out here. There we go. Kind of looks like the isopropyl. That should make sense, seeing as it has that same prefix there. So here, except here you have the 4 carbons, like that. That's the difference there. Next this is an important one to know. Tert-butyl. Or T-butyl. That's also something I should note. So these can be called T-butyl, and then the sec-butyl can also be S-butyl. Whoops. This can also be known as S-butyl. The tert-butyl looks like that. So I often draw it. You have the 1, 2, 3, 4. There you go. Looks kind of like a fork. The fork butyl group. All right. Have those listed. Now I think I'm going to talk about the different degrees of carbons. So let me do that. Carbon degrees. So if you've taken a biology class or a biochemistry class, I'm sure you've heard of the different degrees of a protein or stages of a protein. You have primary, secondary, tertiary, and quaternary. Now, the same thing is for carbons. Actually, you can have a primary carbon, you can have a secondary carbon, and so on. So I'm going to go through these. So first, primary carbon. And these are important to know because they can help in distinguishing structures. Because it's good to know what is bonded to what, and that's what these will tell you. So primary carbon, that means it is bonded to one carbon. If I were to draw it out here, H, and then I'm just going to do an R group, and then that means this can be anything. Like it could be, that could be a CH3. That carbon would be bonded to the carbon. I'm just going to draw R. That's bonded to one carbon. That makes this 1 degree. Next, secondary carbon. It's pretty straightforward. Bonded to 2 carbons. Hydrogen, hydrogen. R group, 2nd degree. Quite straightforward. I mean, it's the same thing for tertiary and quaternary. Very straightforward. I'm going to draw these out. There you go. Now I'm going to run through an example here. Then you can pause the video and try to do it yourself. So here I'm going to draw this structure. Try to make it legible. CH2 there. Now I want you to find the degree of this carbon. I'm going to call it carbon A. I want you to find the degree of this carbon. I'm going to call that carbon B. Find the degrees of carbon A. Find the degree of carbon B. All right. Now, pause the video. You could have solved this. So let's look at carbon A here. So this is where it's at. We're going to look at its group. So here we can already see that it has a hydrogen there. So, okay, that means it's obviously not going to be quaternary. But let's count the direct carbons that are bonded to it. So we have 1, 2, 3. Any more? Are there any up here in this area? No, that hydrogen's there. So that makes this, whoops, that makes this bonded to 3 carbons, which makes it a 3-degree carbon. That's tertiary. Now B, here it has, oh, it's different. It has 2 hydrogens bonded to that carbon. So it's not going to be quaternary. It's not going to be tertiary. That's the most likely thing. So we're going to look at what it's the carbons that it's mainly bonded to. So you have 1 here, 1 there. I'm not seeing any others. That looks about it. There's nothing out here. There's nothing out here because those are hydrogens. So that one is a 2-degree carbon. That is secondary. Awesome. All right. Now, I think that's where I'm going to end this one. The next one I will be going over is some nomenclature. But I believe that I should have that in its own video because I would like to delve deep into that one. That one is quite fun. So if you would like practice finding your degrees of carbons, remember isopropyl, sec-butyl, isobutyl, and tert-butyl. Those are very important to know, especially when you get to naming these alkanes. Very important to know. And that will do it for this lecture. Thank you for joining me. Thank you for watching Tablet Teaches. I hope you enjoyed our lesson today. And if you did enjoy it, why not like and subscribe? It's free, and you can always change your mind later. If you're doing that, might as well hit that bell, get any notifications of when we upload. And I hope you have a blessed day. Good luck in your studies.